Right, so we're back for the rapid revision 02, the structure of lipids. Moving on. Okay, this is the general classification of lipids. Saponification is hydrolysis of an ester with a base, which makes a soap type product. So basically the ones that are saponifiable, we can in principle make soapy things out of them. This is quite important in the structure as well, because many membranes are associated with that type of structure. From a food and nutrition perspective, we're mostly interested in simple lipids, though probably not so much waxes, but fats and oils are obviously right within our ballpark. Phospholipids, glycolipids, sterols and hormones are obviously important in nutritional terms, but they're a bit outside the scope of this particular module. And as I say, food science and chemistry. Yeah, so there's somebody washing their hands in a COVID manner. Yeah. Okay. Long chain carboxylic or fatty acids. Fatty acids, it defines long chains of carbon atoms terminated by a carboxylic acid group. Now when drawing these, it's convenient to exclude the carbons and the hydrogens. You'll see this in books, it just becomes hideously complicated. So if you look at the end of the molecule here, it appears to be just a zigzaggy thing, but this is actually what it consists of. So we have this long chain of carbon atoms and associated hydrogens with a carboxylic acid group at the end. That's a fatty acid. Often we'll reduce them simply down to the R group. Remember, the R group is the rest of the molecule. In this case, the first case on the left, the CH-O bond group is, carboxylic acid group is drawn out. In this case, it isn't. But it's the same group. If you compare the structure of fatty acids with those of fat-soluble nutrients like beta-carotene, they both have long chains of carbon atoms. There's a principle in chemistry that says that like dissolves like, which is why fat-soluble vitamins A, D, E and K will dissolve in fats and oils and can be stored in the human body, unlike water-soluble vitamins such as vitamin C that can't be stored. So there, again, there's some definitions there. So the long chain we often refer to as the aliphatic chain, which is insoluble in water, and the carboxylic acid head, which is soluble in water. So the simplest lipids are the triglycerides, which essentially is a glycerol backbone to which three fatty acids are bonded by ester groups. So they're drawn out a bit there. There's a simple form there. There's glycerol, and there's glycerol drawn out a little bit more complicated. Glycerol is a colourless, odorless, viscous liquid, sometimes called glycerine. The ester group is often drawn in the simplified form shown in the main diagram here on the right rather. Don't forget, however, the structure is a little bit more complicated. When drawing chemical compounds, always make sure you take account of how many bonds elements actually form. But in many cases, the diagram on the left is diagnostic for what we need to understand. So it's glycerol backbone to which three fatty acids are bonded. Okay, you've certainly come across the term saturated fatty acids. What that means is there's no double bonds in the aliphatic chain. There are double bonds up in the carboxylic acid end of the molecule, where the carboxylic acid residues are. So when we say saturation, no double bonds, we mean in the chain, not in the ester group. Saturated fats tend to have a higher melting point compared to unsaturated and are often obtained from animal sources. And consumption is linked to a higher incidence of cardiovascular disease. So it obviously has some nutritional implications. Unsaturated fats have more than one double bonds in their carbon chain, typically obtained from plants and are liquid at room temperature. These are not linked to increased levels of cardiovascular diseases for reasons associated with the fact that they form a kink in the chain. We'll probably talk about this a little bit more later on in the module. Generally we use trivial names, such as linolenic, rather than full systematic names, but it's important to be sort of aware where the chain starts. So the chain starts, in this case, in this nomenclature, over at carbon atom number 1, which is carboxylic acid carbon, and then it produces this big long complicated name, which is basically just saying that it contains 3 double bonds, and they're in the cis format. And it's got It's octane tridecanoic acid. So have a work out how many carbon atoms are in it. Oh, I've told you that it's 18, isn't it? So decanoic means 10, octane 8, so 10 plus 8 equals 18. Sometimes the omega nomenclatures are used. In this case, the numbering starts at the terminal methyl group, which is the CH3 right at the end, so on the right of the molecule here, where the omega is indicated on the bottom molecule. In this case, we've got a 18,3 fatty acid, again indicating that it has 3 double bonds in it, and the numbering tells us where they start. They always appear double bond, then a gap, double bond, then a gap. So once we know where the first one is, we know where the next 2 are as well. I'll probably do a tutorial on the nomenclature at some point. Okay, that's all for that.